Hello and welcome to this short presentation on concentrations. As usual, I do expect you to watch these videos with some previous knowledge. Particularly here, you should be comfortable with the idea of converting between cm cubed and dm cubed, and you should know what a mole represents. When we talk about concentration, a lot of people kind of think, that's when I think really hard, isn't it? Well, yes. But in terms of everyday concentration, you do come across it quite a lot. So in washing powder, quite often on the washing powder, it might have double concentrate. Or on your washing up liquid, it might say concentrated washing up liquid. Or you might have concentrated squash, where if you put a little bit of squash in, it looks like this. But if you put a lot of squash in before you dilute it, it looks pretty different. Well, concentration really is just a measure of how much of something there is in a particular volume. And when we talk about concentration in chemistry, well, I might take some water or a beaker of water and I might add a teaspoon of salt. And then I get some ions here. So I've got ions, sodium ions, and I've got some chloride ions, which is brilliant. And then if I take another beaker with some more water, but in this case I add 3 teaspoons of salt, then what we might be able to say is that B is more concentrated in terms of salt than A, or A is less concentrated than B. But is there a more scientific way of doing it? Well, the answer is yes. So we're going to define concentration in 2 different ways. The first way is the amount of mass dissolved in a volume of solvent. And the second way is the number of moles dissolved in a volume of solvent. Okay? The important piece of information here is that the standard unit of volume when we're discussing concentration is 1 dm cubed. And just to remind you, that 1 dm cubed is equal to 1000 cm cubed, and you may need to do some conversions between these. So you should be comfortable with that. Okay, we're now going to define these 2 ways. The first way is the amount of mass dissolved in 1 dm cubed, or in grams per dm cubed. So here is an equation. So the concentration in grams per dm cubed is the mass divided by the volume in dm cubed. Okay, that should be to the power of 3 then. Or the second way is the number of moles now. The number of moles dissolved in 1 dm cubed, or moles per dm cubed. Another equation, the concentration in moles per dm cubed is the number of moles divided by the volume. And we're going to do a couple of examples of this. Okay, so an example here using grams per dm cubed. Well, if I take 50 grams of sodium hydroxide and I dissolve it in 200 cubic centimeters of water, what is my concentration? Okay, in grams per dm cubed. Well, remembering that grams per dm cubed is mass divided by volume. Okay, you might find this equation triangle helpful. Some people do, some people don't. Then what we need to do is we need to convert our cm cubed to dm cubed. So it's 200 divided by 1000 in this case, and that equals 0.2 dm cubed. And then I need to divide the mass in my question by that volume. In this case, I've got 50 grams of sodium hydroxide, and I'm going to divide it by 0.2 dm cubed. So the concentration in answer to this question is 250 grams per dm cubed. How about a moles example? Well, if I take 50 grams of sodium hydroxide and I dissolve it in 200 cubic centimeters of water, or, as stated here, 0.2 dm cubed. What is this concentration of the sodium hydroxide solution in moles per dm cubed? I need to calculate the number of moles of sodium hydroxide. My relative formula mass of sodium hydroxide is 40. So the number of moles that I have is 50 grams divided by my MR, 40, and that equals 1.25 moles. We then use our equation triangle, if we like, number of moles, concentration, volume. I need to divide the moles by the volume. And in this case, 1.25 moles divided by 0.2 dm cubed, which means I get 6.25 moles per dm cubed. Now, just to highlight here, this also equals 6.25 molar. The M here stands for molar, and it's something that we've probably come across when we're talking about acids or alkalis in the past. One final thing to show you is that we might need to convert between grams per dm cubed and moles per dm cubed. But we know that moles is the mass divided by the MR. So actually, the conversion becomes quite easy because our concentration in moles per dm cubed is equal to the concentration of my concentration in grams per dm cubed divided by the MR. Or you could say that the concentration in grams per dm cubed is equal to the concentration of in moles per dm cubed times by the MR, depending on exactly what you get given. So thank you very much for watching this short presentation. Come back next time. Why don't you like and subscribe?